So I'll open our class folder and then we can start from where we left off yesterday. So yesterday I gave you guys an assignment to try out, and yeah, we can start by solving that. So I'll run this first line here, which is for importing all the libraries in the notebook that I shared with you on simple linear regression. Then I'll head over to this part here, but instead of me using this notebook, and we will be covering a different topic for today, so let me create a new notebook called multiple underscore linear regression. So this is our notebook for today. Okay, so the theory is same here, but what our aim will be to have y being equal to m1 x1 m2 x2 m3 x3 up to mn xn plus b. So these m's here are the different values that we have that can be multiplied by the different features that we have. Okay, so that's the equation that we have. So let me copy the libraries that we were using yesterday and import them here. So we have this. So we are importing numpy, pandas, matplotlib, seaborn, and warnings. And we are also filtering all the warnings that we get. Okay, let me save that. Then again, I can copy this code part here for the assignment part. Then we can fit our simple linear regression model first, just to see how we could have done our assignment yesterday. So this is what we have. So we have flights, then the data set itself. Okay, so if I was to approach this project, so with what I had taught you yesterday, so I will check for two columns which are numeric, and I can do that by typing in flights.info. And if we check flights.info, you can see we have the year column, which is an integer, and we have the passengers column, which is an integer. And if I was to come up with a task here, so like a model that I want to make predictions with, it would be a model that can predict the number of passengers based on the year that we have. So here I will say that let my y be equal to passengers, right? Then my x should be equal to the year. Okay. And then what I can do is I can do some basic EDA. So for those who contacted me today, I mentioned that what you could have done is you could have created a heat map. So to create the heat map, I will type in sns.heatmap. Then I'll just have to use the correlation values here for flights so that I can get the correlation in between year and passengers. Then I can run this. So we have sns.heatmap, then we have flights.code. Okay, let's see, could not convert string to float. Okay, so let's see if I run this outside what I'm supposed to get. Yep, so here I'll select the two columns. So we will have year and we will have passengers. So this is small y and that is capital Y. So this is the correlation that we are having. So I can say something like code should be equals to that. Then I can print out the correlation. So core is not defined. Let me run this again here to declare my variable called core. So here you can see for passengers and here we have a high correlation. So which means that, okay, so the correlation is at 0.93, so which is close to 1. So this means that the year that the passenger comes from really affects like the number of passengers you can have. And this is the EDA part. So another thing we can do is we can create a line plot for the number of passengers over time. So what I will have is we can have our data being equal to df dot group by here, then we get the sum. Okay, so it should not be df, but this should be flights. Then we group it by here, then we get the sum. Okay, so we have an error, so category type does not support sum. So what I can get here is so here I can get the number of passengers. And if we check our data, that's what we have. So you can see we have the year and the number of passengers. Okay, and this is our data. So I don't know if we have more observations. So basically that's what we have. So if I type in maybe data dot shape, it's a 12 by 1. So this is the year, then this is the number of passengers. So this is all on the EDA part. So you had to like group all those years into one and get the number of passengers because we are dealing with simple linear regression. Okay, so then the next thing we are going to do is now create our y and x. So I'll type in data dot columns to see the number of columns we have in the data. And I think this is a series object, so we have no columns. So what I'll do is I'll convert the index. Sorry for that. So I'll convert the index to be a column. So we will have our data and we are going to reset the index so that if we check our data, this is what we have. So we have the year and we have the number of passengers. So you can see this data is somehow different from what you had. So let me summarize what we've done from the beginning. So first of all, I had to check the correlation between year and the number of passengers. And as you have seen, we have a high correlation there. Then the next thing I had to do is you have to notice that, for example, if I type in flights dot duplicated dot sum, you can see like it's saying no duplicates here. But if I select the year column, right, and I type in duplicated dot sum, you can see we have 132 duplicates. So this basically means that I'll have to aggregate all these years together so that I can come up with something like this, so a shorter form of the data. So I use the group by, and once I use the group by, I reset the index for us to have a data frame. So now after we've got our data frame, the next thing is to create our y and x variable. So our x should be equals to data, then we select here. Then our y should be equals to data, then we select the number of passengers. So we can run that. So that's what we have. So today we are using two square brackets. So instead of using what we had here, the dot value, so a different way of approaching this. And this is our step one. Okay. Then the next thing we are going to do is we are going to import our linear regression model. So we are going to have from sklearn dot linear model import linear regression. Then the next thing we are going to do is to instantiate the model, and our model should be equals to linear regression. So just give me a minute. I need to inform someone that I'm in class. Okay, apologies for that. Let me proceed. So we've instantiated the model. So the next thing we need to do is fit the model. So we have model.fit, then we have our x and y. Then we can run that. So here I won't be making any predictions. So I'll just pick a random value here and say predict. So here, predict how many passengers will be in the year 1952. So we'll have model.predict, then we pass in the exact value 1952. So if we run that, you can see we have 2405 passengers. So if we compare this to what we have here in the data, so this is 1952. So 1952 we had 2364 passengers, but here it's saying we have 2405 passengers. Okay, so here we can have our ypred being equal to model.predict. Then I'll pass in my, okay, so what will I pass in? So I'll just pass in my y. Then we can run that. Okay, the feature names should not match those that were passed during fit. Okay. So I'm not supposed to pass in y, but x. Sorry for that. Yep. So we've now made the prediction. So what I'll do is I'll add the predictions to the data frame. So we will have our data, then ypred being equals to that. Then we can print out the data. And here you can see what's happening. So you can see as from 1949, these values keep on increasing. So 1949, the actual value was 1520, but the predicted was 1256. In 1950, the actual value was 1676, but the predicted is 1639. So you can see the predictions are a little bit closer to the original values that we have over here. And that's how you could have approached this project. So that's the solution for the assignment. So let's now start the multiple linear regression part. Okay, and here we have our flights data. So if I type in flights.head, this is what we have. So before we fit in our model, we need to do some data pre-processing. And for data pre-processing, a few things we can do is encoding. And another thing we can do is, so for today we will only cover the encoding part. So how do we encode categorical variables? Okay, so this is the first thing we are going to do. And for encoding, yes, can you hear me? Yeah.
Now, sorry for this, but I have to ask this in regards to when generating on when coming up with the x
Yeah.
and y for the model.
Yes.
Just go back up, just scroll up up to yeah somewhere there.
Yeah.
When you are creating those variables,
Yes.
the other ones we're using the x and the x and the sorry the dot value
Yeah.
and then going to reshape.
Yes.
Now, I would like to know this. Now, I don't know if it is what I'm thinking about, but is it because the year can't go back to negative? Is that the reason why we don't have the reshape?
No, we can
Otherwise,
have the reshape also. So what I can do is I can copy this part here. So the difference is here you can see we have a single bracket, but here we have two square brackets. So that's what's making the difference.
oh, okay.
So we can have dot values dot reshape. Then here again we can also have I can remove this extra square bracket, then we can have dot values, so that if I run this again using what we had in yesterday's class, you can see we are still getting the same outputs. So I'm just trying to like come up with different ways of like solving this problem, so that by the end of the course you will have like different approaches to like the projects you are doing.
Okay, get
Yeah.
the point.
So for today we
Joseph,
are using the two square brackets. Yeah. Yes.
sorry, but what does the two square brackets indicate?
Okay, so
What does it mean?
if we type in like if we say like data then year and we include only one square bracket, so here we create a data series, right?
Yes.
But when fitting machine learning models, so if I type in that and I paste it like that. So here we create a data frame. So when working with pandas series, so you'll not be able to like fit models with the series as they are directly. But when you are working with data frames, you can fit them to the model without you having to reshape them. Okay? So that's the only difference. So if you decide to work with the pandas series, you will have to use the reshape method here. But if you decide to work with a data frame, then there is no need for you to like reshape. And this is how you like select a part of your data frame. So here we are selecting only a single column. So do
Okay.
you get it?
And then I have another question. Sorry.
Yeah.
The part where you were doing 1 minute.
The group by,
The modeling,
yes,
and you put the code, you put the equals on the right is equals to y underscore predict.
this part here,
Oh, like why isn't it the other way? Yes, the down one,
this part here.
the next one. Yes, that one.
Okay, so here we are creating a new column called ypred. So what we do is we index that column first. Then after indexing that column, we assign to it values by using the equal sign. And the values should be stored in ypred. So we copy what is in ypred and paste it in the ypred column in our data frame called data. So do you understand that? So for example, if I wanted to like add a new column, so let me add a new code here. So if I wanted to like add a new column here called ypred passengers. So first of all, I would have to like index that column. So you can see in our data here, so we don't have like, so if I run this, we don't have the ypred passengers column here.
Sorry, Joseph, I think yours okay. Oh, it
Okay.
was hanging. Okay.
Okay, yeah. So here we don't have the ypred passengers. So if I want to add the ypred passengers column here, I'll have to come down here and index that column first. Then after indexing that new column that I want to add, I have to assign it to it values. And these values are stored in a variable called ypred. And if I run this and we output our data, you can see we have now the new column called ypred passengers. And that is the reason as to why we have like this part with the column name on the left hand side and this part with the values on the right hand side, because we are assigning these values to this column. Do you get it?
Yes, okay.
Yeah. Any questions before we proceed? Okay, so if you have no questions, then we can proceed. So here we are on multiple linear regression, and here we are looking at the encoding of categorical data. So there are three ways in which we can encode categorical data. And the first way is we can use the pd dot get dummies method. Okay. So that's the first way in which we can encode variables. And another way we can encode variables is by using one hot encoder. And this is the same as, so works the same way works the same as pd.getDummies. Then another thing we can do is we can use label encoder. And the last thing we can do is we can map. We can map our values, okay? So we can use the map function. So what I'm going to show you is the pd.getDummies. And so for this class, I'll show you these 4 things here. And you'll get to decide which one works for you best. So before we proceed, I'll have to demonstrate how the pd.getDummies method works. So we are looking at the pd.getDummies and one hot encoder. So I'll create a new drawing here, then I'll show you how it works. Yeah, so let's assume we have this table here, okay? And here we have our variable y and we have our variable x. And this one has 1, 2, 3, 4. Then this one has the values o, x, y. Okay, so if I was to use the pd.getDummies method, then this is the output I would get when encoding these values. So remember, these are strings, right? And these are integers, so I'll have to type in int. So these are strings and these are integers, so which means that they are numbers. So another thing you need to note is ML only works with numbers. So when fitting machine learning models, you have to like convert all strings that are there in your data to be numeric. So here we have OOXY, or maybe I can change the OO to something else so that I won't confuse you. So here we can have M, then XY. So if I was to do the pd.getDummies, so I will get this extended table over here. So the first column here will be my y, and my y will have the values 1, 2, 3, and 4. But then for my x column, I will have xm. Okay, and xm, since this column here has, so you can see this column row 1 and row 2 have m in them. So here I will have 1 and here I'll have 1. Then for the other columns I'll have 0, 0. Then we will have a third column. So this will be xx, and this will be 0, 0, 1, 0. Then we will have also another column, so called xy. So this will be 0, 0, 0, 1. Okay, and I can explain this new table that we have over here. Okay, so this table here, when we have the value 1, so it means that this value exists there. But if we have the value 0, then it does not exist. Okay, so that's what it means. So here, when we have column xm, so we are checking for if the values here are equal to m. So in row 1 we have an m, so we have 1, so which means that this is an m. In row 2 we have an m, so here we have 1, which means that that is an m. In row 3 we don't have an m, so it's at 0. So for column M, it's 0. For row 4, we don't have an M, so it's 0. So here you can see this is where an M was, this is where an M was. Then this was not an M, this was not an M. So if we go to column X, so here we did not have an X, here we did not have an X, but here we had an X. But here we also did not have an X. Here we did not have a y, here we did not have a y, same for here, then here we had a y. So this is how the pd.getDummies works, okay? And Yeah, hope you've understood that. So that's how the pd.getDummies method
Yes,
works.
yes.
Yes,
Basically, that's my understanding. That's
yeah,
according to my understanding.
yes,
It simply means that we are talking about the integers and the strings, right?
yeah.
In
We
the
are
previous
talking about
videos,
the integers and the strings.
right? So from y, there's integers in y
Yes,
and strings in x, right?
yes,
But M1 now speaks for the first column which has a string. Um, so M, and given that in this case we are having different values MM, and these ones are different. So I would like to understand, are we talking about values that are in the column names, or we are talking about very different values,
no, we
or
are
you
talking
just use
about
it as an example?
values that are in the column. So I can show you like a real world example and you can see how it works. So I'm going to create a new data and my data should be equal to pd.dataframe. Then I'll open brackets. So here I'll create a dictionary. And for this dictionary, I'll have my employee ID, for example. And then next we can have the salary and age, and we can have the department lastly. Yeah, so that's what we have. So I'll have to enclose these in these brackets, but let me use something shorter so that you can understand this better. So here we will have like my number. So my number can be equal to 1, 2, 3, or 4, comma. Then we can have my department. So for my department, I'll have sales, HR. Then if I print out my data, this is what we have. So you can see we have, if we check the data.info down here, if I check my data.info, so you can see we have, so data.info, sorry for that, you can see that the number column is an integer column, but the department column is an object column. Okay, so we'll need to convert these objects that are over here to be numeric. And how do we do that? So what we do is I'll add another code here and we will type in pd.getDummies. Then we will type in our data, then we will specify the columns that we want to convert. So in here, we create a list of all columns that we want to encode. So for example, if I added a new column here called maybe country, right? And let's say we had US, UK, and we have an error here. There is something I need to fix. Still an error. Yeah, so everything is okay. So if I run that, you can see we have two categorical columns. So two columns that have objects. So here, after department, I'll add another column and type in my country column. So that if I type in pd.getDummies, this is what I get. So we have number, department HR, department sales, department UK, then country US. And here you can see we have these false, false, true, 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 false, false. So here you can see, like, for example, let's look at the department first. So is it department HR? So these first two rows, are they department HR? So it's false, false, right? So it creates the false, false values. But for these two values down here, they are true. Then is it department sales? So here we have true, true, false, false. And remember, in Python, okay, so in Python, true is equal to 1 and false is equals to 0. And this is basically what I was showing you here. Like we have 1100 and that's the output of this table that we have down here. So it creates like new columns for every categorical variable that we have here, and it checks if what we have in here in the column values is equal to what is there in the column name, and it assigns that the true or false values. So that's the first way in which we can do the encoding. And actually what we can do is we can drop first to avoid repetition. So for example, if we know that the department is not for HR, so if we have two departments here, so if the department is not for HR, automatically we will know that the department is for sales. So if I run this, you'll see we will have only the department sales and the country US, because we only have two variables which we can compare. So if the department is not for sales, then we automatically know that that department is for HR. Another way in which we can do this is we can use one hot encoder. So this is the PD get dummies. So one hot encoder, so we will have to import it. So we will have from sklearn dot preprocessing import one hot encoder. Then we will have to instantiate the encoder. So one hot encoder, so here it will be our encoder, should be equal to one hot encoder. Then here we can remove these hyperparameters because we haven't started the discussion on them. And then this is like fitting a machine learning model. Then we fit the encoder to the data, and we will have encoder.fit. Then we will have our data, and we will pass in the two columns that we want encoded. And here you will see we will have an encoded variable. So after fitting that to our data, we will have to add them back again. So here instead of fitting, so we can do the fit underscore transform. So we fit the data and transform it at a go. Then next, what we do is we create a data frame with the encoded data, and that will be equal to pd dot, so pd dot data frame, then encoder dot fit transform, then we convert it to array, then all that. So I don't know if that will work. Okay, so let me delete this first. Yeah, and this is what we have. So you can see we have ones and zeros for these two column names here. So this is basically what happens. So this is a representation of this table that I was showing you here. So we are creating the ones and zeros for these columns that we have over here. So this first column here is the department. So if I remove the drop first part here and I run this, so here you can see we have department HR. So department HR is column 0, where we have 0 0 standing for false and 1 1 standing for true true. Then we have department sales in column 1, we have 1 1 and 0 0. So for that and that. And basically that's how one hot encoder works. But I'll demonstrate how this works more better while we will be doing the course. So in another class, I will demonstrate how this works better. So this is just to show you the different ways in which we can encode. So I'll not show you the label encoder for today, but I'll show you the map part for today, because I believe it's better we use the map for today's class. Then we can fit our multiple linear regression model. So we have our flights data set. So this is our flights data set. So what we will do is I will create something called a DMAP. And a DMAP is a data mapping. And here we will have something like, so if I check in my months, so if I type in flights, then I select then month, then I check the unique values. Here you can see we have January, February, March, April, May, June, July, August till December. Okay, and these are categorical. So what I'll do is I'll have my DMAP being equal to, so I'll create a dictionary, and this will be equal to Jan, So Jan will be month 1, comma. Then we can have Feb. Then it goes on. So May. Then we can have June 6. Okay. So we have that. So we have everything here from January, July till December. So after I've created my D map, so it's a dictionary. So here we have our D map. You can see it's a dictionary. So with each month as the key and each month number as the value. So what I'll do is I'll select the flights column, then index the month column. So before this, so here you can see if I do that, we have January, February, March, April, May, June, July, August, September till October. Then what I can do is I can say let this be equals to flights. Then I select the months column again. Then I use the map function. Then I use the dmap, so the data mapping that I have up here to map all those values. Then I can run that. So if I type in flights.head again, what you will notice is that the month column now has numeric values instead of categorical values. And as I had mentioned earlier, so machine learning models work best with numeric values. Okay, so what we can do now is we can create something like a heat map. So we can have df, no, not df, but flights dot core. This is our correlation map. And yeah, that's what we have for correlation. So for each month, I think the months should be categorical. Okay, so what do we do? What do we do? So I'm going to create a pivot table. And the pivot table will have each month and year with the number of passengers that correspond to that month. So we will have flights being equal to flights.pivot table. Then the index should be equals to the month. The columns should be equals to the year, and the values should be equals to the number of passengers. So this should be flights underscore pivot. So if I type in flights, then underscore pivot, this is what we get. And actually I can go ahead and create a heat map for this. So we will have then create a heat map. So we will have sns dot heat map. Then we will have that. Then I can use the Viridis color. And this is what we have for our heat map. So if I was to interpret this heat map, so I'll need to add a few things. So I'll have a note being equals to true, something like that. Yeah, so this is our heat map now. So this is the code that I'm using. So I've just added a note being equal to true and font color to that. So here you can see like from 1949 till 1960, the number of flights kept on increasing. So, and this can be noted using the color map here. So here you can see in 1949, we had roughly 112 to 140 flights. But in the year 1960, we have flights ranging from 400 to 600. So, and looking at this heat map again, you can see for month 8 and month 7, which I think is for July and August, we have more flights as compared to all the other months. So in December, the flights increase, but not as compared to these mid-year months. So June, July, and August. So those are the years where the number of flights increase. So now that we know how our data looks like, so I can create another EDA plot called a cluster map. So I'll create a cluster map. So we will have sns.cluster map, then we can have this. So the cluster map will show us a clear interpretation of how these months relate with each other. So you can see 1949 and 1950 are under the same category, 1953 and 1954 are the same category, and like that. So if you are interpreting these y-axis values, then you'll have to look at these lines that are up here. And if you are interpreting the x-axis values, then you'll have to look at this. So for example, for month 8 and 7, you can see they have been grouped together because these are the 2 months where we have like an increased number of flights. So things like that. So you can go through this plot once I've shared the notebook with you guys. And the next thing for us to do will be to fit our model. And that is the multiple linear regression model. So first of all, we will have to create our y-index variables. So to create our x variable, we will have flights dot drop. Then I'll drop the passengers column, and the axis is equals to 1. Then for our y, it should be equals to flight. Then we select the passengers column. And you can select it as a whole as we were doing up here, or you can use just that single bracket. And that's what we have. So if we check our x, that's what we have. If we check our y, that's what we have. Then the next thing is to import and instantiate the model. So here we'll have from sklearn import from sklearn.linear model import linear regression. After importing linear regression, we instantiate the model. So here we'll have our model being equal to linear regression. Then lastly, we fit the model. So we will have our model dot fit. Then we fit our x and y. Then we can run that. So before making any predictions. So after fitting the model, so what we can do is we can extract our model coefficients and the model intercept. So here extract the model coefficients and intercept. So we will have print model coefficients, model coef, then print model intercept, then that. Yeah, so these are our model coefficients and these are our model intercepts. So I can add some notes here. So in our data, we had two features. And the two features were year, and the year column has a model coefficient, has a coefficient of 31.055. And again, we have the, so which other column did we use? So we had the month column, and the month column had a coefficient value of 2.20, and the intercept of the model intercept is equal to this. So that's our model intercept. Okay, so if we were to incorporate the linear regression equation, so the multiple linear regression equation, we will have our y being equal to this equation here. So 31.that multiplied by a year, then the 2.2 multiplied by the month minus this, because you can see our intercept is negative. So I can copy this equation here, and we can go ahead and try make a prediction using sample values. So let's say we had how many years here? So I can use 1950 as the year. So here I'll have 1950. Then the month, let me have month 8, which has the highest number of flights. So month 8. If we run this, so this is our y1, so not y1. So our y1 should be equal to 139.947. Okay, so let's confirm if that's true from the model. So we can have model dot predict, then we pass in the two values 1950 and the 8. So if we run that, you can see we get a prediction of 139.94 721. Then we can go ahead and create our ypred. So we will have our ypred being equal to model.predict, then we pass in our x. So x is our features data, and we are trying to come up with predictions for our y. And then we can run that. And lastly, what we can do is we can plot. So we can plot the predictions against the actual values. So that's what we have. Again, I think we can use this plot that we had yesterday. So let me paste it here. So here we have our straight line. So this straight line here shows you like the predictions that have been made. So you can see this straight line tries to like cover everything that we have here. So these are the predicted values and these are the true values. So this straight line also takes us back to what we had in our class yesterday. So this same plot that we had here. And it's a line that is trying to like show us how we can come up with predictions based on the values that we have in here. Yeah, so I think that's all for multiple linear regression models. So you have to understand this equation. So whereby you have now multiple predictors. You don't have like a single predictor. And this part, the other part that you have to understand is this part here, where you are creating your X and Y. And another thing I've shown you today is the encoding. So I've shown you the get dummies method and I've shown you the one hot encoding, but we haven't applied them yet. So we will apply them. So all I wanted to show you guys is how you handle these categorical variables, and I've shown you using the map function. So the map function only applies where you have like an accountable number of variables whereby you can easily encode them using the map function. But if that's not possible, you can go and use the one hot encoding or the get dummies method or the label encoder. So any questions on what we've looked at? So we'll have an assignment. So we will have the Boston housing data from sklearn, not from sklearn. So we will have Boston being equals to that. Then Boston.head. Let's see what we get. Okay, so Boston is not an example data, so we'll have to import it from sklearn. Let's see what we get. Yeah, so this is the Boston house dataset. Let me see if I can get another simpler dataset that you guys can work with. Let's work with the attention.csv file. So this is the attention dataset. So what I want you to do is, okay, so these are the assignment rules. So use the, okay, so first of all, delete the unnamed column 0. Then next is encode the attention, encode the attention column. Then create a linear regression model using the score as your target variable and all other columns as your features. Okay, so that should be your assignment for today. So I'll upload this notebook to the same drive folder that we've been using, and you can go ahead and attempt that. Yeah, so any questions on what we've covered